Question number 3. So I've got g of x, a polynomial function in its factored form, and the first part is asking me to find the leading term, an times x exponent n. And to do that, I'm going to consider each of those 1, 2, 3, 4 factors, but I'm going to take only the leading term of each. So here it only have one, it's 1 over 9. Here I will have x, but I'm not going to forget to apply the square. Here I've got 3x exponent 1 and x squared. So I will have 1 over 9 times x squared times 3x exponent 1 times x squared. Now here it's not really necessary, but I'm going to take this extra step to make sure that I cover all our bases. So here I will have 1 over 9. I'm going to apply each of these exponents. X squared is just x squared. 3x exponent 1 is 3 exponent 1 times x exponent 1. And this is sometimes the mistake that I see, is that whenever you have an exponent, you forget to apply that also to the coefficient, and then times x squared. And if I compile that, so let's take care first of the coefficients. 3 divided by 9 is 1/3. And I have x exponent 2 plus 1 plus 2 is 5. From that leading term that I got, without having to distribute the whole polynomial, I can conclude the n behaviors. That is, the behaviors, the limit as x approaches negative infinity, and as x approaches positive infinity. Now, because I have an odd degree, n equals 5, that means that I'm going, just like a line, is going to go down to the left and go up to the right. And I'm going to keep it that way because an is positive. So I will have negative infinity as x approaches negative infinity, and positive infinity as x approaches positive infinity. To find all the intercepts of y, so there are two types of intercept. The first one is the y-intercept, and to get it, I just need to evaluate g of 0. So I'm going to replace x by 0, so I'll have negative 1 squared times 2 exponent 1 times 3 squared. And here, so this is 9, over 9 is 1, negative 1 squared is positive 1, so I will be left with 2. So the y-intercept would be 0, 2. The second type of intercept, it's the x-intercept, and to get those, I need to solve, not just evaluate, solve g of x equals 0. But because the factored form is given to me, it's rather easy. I'm going to have x minus 1 equals 0, or 3x plus 2 equals 0, or x plus 3 equals 0. And therefore, that means that x belongs to the following set: 1, negative 2/3, and negative 3. So I'm going to conclude the x-intercepts would be 1, 0, negative 2/3, 0, and finally negative 3, 0. And then I'm notice that to solve the equation, to find the zeros, the roots, I did not bother about the exponents. But then I'm being asked the multiplicity of each zero. So I'm going to list, once again, those zeros. So I have 1, negative 2/3, and negative 3. And then I'm going to indicate the multiplicity. So here I just need to refer to the exponents that have 2, 1, and 2. 2, 1, and 2. So I've got a little chart here, and that will be enough for me to sketch a decent graph. So the first thing that I'm going to do is to plot those zeros. So I've got 1, I've got negative 2/3, which is negative 0.6 repeating roughly here, and finally negative 3. Now I will have the y-intercept 0, 2, and then I can use my calculator to find the maxima and minima. So 1/9 times x minus 1 square times 3x plus 2 times x plus 3 square. And if I graph it, I have something like this. And I want to find this minima here and this maxima right there, which is awfully close to the y-intercept anyway. So let me start with this minimum here. So second trace, I want to find the minimum, so I'm going to type 3. Left bound, so I'm going to go to the left of this minimum, press enter to validate. To the right, press enter, and somewhere in between, and I will have negative 1.7, negative 4.26. So let me plot that roughly. Negative 1.7, that's roughly here, and to the other side actually, and negative 4.3, so that's going to be roughly here. Okay, now I would find out that this maximum here is in fact awfully close to the y-intercept. Now, I know that the graph will bounce off from the negative 3 and the positive 1 of the x-axis. So that is going to be enough for me to sketch a decent graph of this polynomial. And here you have it.